everybody, welcome back. We're going to be going through our proportionality notes today. Again, just kind of a refresher of algebra, and hopefully this should be familiar to you. If it isn't, come see me and talk to me about it, but we need to brush off that rust from the summer again. So we're going to be talking about proportionalities today and how as one value changes, another value changes accordingly or at a certain rate. So in physics, we're concerned about proportionalities with a lot of things. Maybe with a car moving, how a car's position changes as time elapses. So time is moving and the position is changing. And if it's changing at a constant rate, we say that has a constant speed or constant rate of motion. So in math, proportionality is simply developing describing the relationship between two quantities. If I walk 3 meters every 1 second, okay, 3 meters per second. That is, and we'll talk more about this later, but this is really position over time. My position is changing over time. Then if I walk 1 second, I move 3 meters. If I walk 2 seconds or more, I go 6 meters. If I go 10 seconds, I walk 30 meters. So that rate of motion is constant. And so we could say that the relationship of position in this instance and time, or the proportionality constant between them, equals 3. 3 would be our description of how x changes with respect to time. Now, typically time is on our x-axis, and give me a second here, because it's the independent variable. So if I were to write a little graph of this, I'll make this black. Okay, that would be time, because time always elapses. It's independent of anything else. And this would be our x position right here. Don't be fooled by the fact that I'm calling this x. It really is just an indicator of position, even though it's on the y-axis here. So this is position, P-O-S. This is time. And so you can see that as I walk at that constant rate, my position would change constantly over time. And this right here would be equal to 3, the value of this, that line right there. Now, I almost said the answer. How can we describe that line? Well, you can say it's straight, okay, but you can also say that it's angled and it has a certain slope. And the slope really is what we care about, and we're talking about how x relates to t. This right here is the proportionality constant between x and t, and that's what we're going to be looking at a lot this year in physics. So we could say, in this instance, that x, or whatever is on the dependent or y-axis value, we could say it's proportional to t if I move constantly at that rate. You could also say that x is, that symbol right there also means proportional. They're related. They have some sort of set, fixed proportionality constant that describes them. So let's look at a few different kinds of proportionalities. The first one I've been describing already, and that's a direct proportionality. Okay, it's like taking making a graph and saying that there's a slope. This is x, or our independent variable. This is y, our dependent variable, and the slope right here. Hopefully that should be a straight line, but if that's a straight line, that is a constant slope. It's not changing. And so as x changes, this right here, let's say right here, that would be our delta x. Remember, delta means change in something, and this right here would be our, I'm messing up already. It's delta y, isn't it? That's delta y. And this right here would be our delta x, right? Then as long as that slope is constant, that change in y, delta y, and change or a corresponding change in x delta x, is always going to be the same. There's a constant direct proportionality. So we say if we say right here that the delta y equals k times delta x, then what does that k mean? Well, if you think back to math, and we have that what should be a very familiar math graph equation, y equals mx plus something else, but the m right here, what does that stand for? That stands for the slope, and that's really what k is right here. M, or the slope, is the proportionality constant between y and x. So it could be said that we could describe how y changes with respect to x as simply being k, or the slope. We call that the proportionality constant, but it's really just the slope the slope of the relationship between x and y. So let me show you a few examples here. Right here, I did this on my iPad. It's got a graphing calculator on it, and right here we have a relationship between x, that's our x, and that's our y. And its relationship is y equals 1/4 x. Okay, so as x, let's look at x is probably kind of hard to see for you right here, but if x is 4, then y would correspondingly be 1. If x is 8, y is 2, and so forth. Okay, so in this case, 1/4, or 0.25, would be y over x. It would be the relationship if we were to divide both sides by x and bring x down right there. Y over x would be 1/4. Okay, let's look at another one. Y is, I think I mislabeled these here. In this case, y, now we have a negative slope. Okay, so that means we must have a negative relationship between y and x. So y is equal to -1/2 x. Again, if we say what is the relationship between y and x, then the answer is -1/2. That downward slope from left to right indicates a negative right there. We can also have direct relationships with shifted y-intercepts as well. In this case right here, y equals x minus 2. Again, think back to math. Our equation for the slope of a line is y equals mx plus b. So what's the slope of this line right here? Well, the slope is 1, or the relationship between y over x equals 1, but we do have a shifted y-intercept. That is, it's shifted downward such that when x is 0, y crosses, or the graph crosses the y-axis at -2. So this is just a slope of 1 where the whole graph is shifted down right here. Okay? But we can also have, you might say, indirect proportionalities. That is, proportionalities to a power. So let's say we have y equals x squared. Okay, you may have seen this before. You may have punched this into your calculator. Here, as x changes, y doesn't change accordingly. Y changes accordingly and is squared. So if x in here and y right here, x equals 1, y would be 1, of course. If x is 2, y would be 4. If x is 3, y would be 9, and so forth. So what we're going to see is that it's not going to be a straight line, it's going to be a curved line. Y being proportional, oops, that's a bad proportional to x squared, okay? Or y being proportional to x cubed, or even y right here being proportional to x to the 1/2. What the heck is that? Well, you can write it like that, but you may be more familiar to see it like this. Y is proportional to the square root of x. X to the 1/2 power is the same thing as the square root of x. So what do those graphs look like right there? Well, right here, there's actually two little things I'm throwing in here. y equals x squared, and I actually added a plus 2. So this slope, which really isn't even a slope because the slope keeps changing, right? Changing, going from negative to positive. Oops. So there is no real slope, but that relationship between y and x keeps changing. And not only that, but the y-intercept is at 2 right here. So it's y equals x squared plus 2. Negative x squared. Or actually, yeah, this is y equals negative x squared. And you can see it looks similar. By the way, this is negative x squared plus, what is it? I want to say that's 4? Plus 4 or 5. It's kind of hard for me to see here. Or plus 3 maybe. Okay, if this were just y equals negative x squared, the graph would come in right there and go back down. But we can see that it's shifted up. So that's this right here is the y-intercept. So wherever you have a relationship, a proportional relationship between y and x, such that one is squared or that the x is squared, you're going to have this parabola form right here. Okay. What if we have y equals, oops, no, turn that on. Y is proportional to, I should say that, proportional to the square root of x. Or you could say y is proportional to x to the 1/2 power. It's the same thing. It'll look like this. We're going to have the parabola kind of looking like it wants to start 90 degrees to the side or turned 90 degrees, but we only have half of it because you can't have square root of a negative number. Y can't be a square root of negative 3 because there is no square root of negative 3. So we have this kind of a half a parabola laying on its side right there. All right, so these are proportional relationships between x and y to powers right here. I keep doing that. Sorry. X and y to powers. Y equals x, or y is proportional to x squared. Y is proportional to x cubed. Y is proportional to x to the 1/2 power, or square root of. So finally, we're going to see what inverse proportionalities look like. And again, these aren't going to be direct straight lines, and honestly we like straight lines. We're going to try to shoot for them in class, but what does y is proportional to 1 over x look like? All right, and by the way, this n right here means x to some power. It could be x to the first, which is just x. It could be x squared, x cubed. All these graphs right here are going to look kind of similar to each other. Y equals 1 over x. What does that look like? Well, let's just do a quick little chart right here. X, y, okay. So if x is 1, 2, 3, 4, then y is going to be 1. 1 over 1 is 1. And then it's going to be 1/2, and then 1/3, and then 1/4, etc. So as x increases, y is going to get increasingly smaller and smaller and smaller. Looks kind of like this. Right here, y equals 1 over x. And we have these two sort of inverted graphs right here, mirror images of each other. Or if you have y equals, or y is proportional to x, 1 over x squared, sorry, it'll look like this, where on the positive end, there's a positive x, and this is the negative x axis right here. On both sides, y is going to be positive both ways, because if you square any kind of number, it results in a positive number. So this type of graph is what a inversely proportional relationship would look like. So we've got 4 relationships. We've got direct, actually kind of just 3, direct, squared or square rooted, and inversely proportional relationships. These are going to be the ones that we're going to talk about most in class, and these are the ones that I want you to become familiar with identifying.